All right, let's take a look at problem number 2. We've learned that when you have an A value, a number in the front, the way we handle that is we make a new Y column. So we have to have a third column, a new Y column. But now we have this B value, I'll call it. When you have a multiplier that's inside the radical, what you're going to do is you're going to make a new X column. All right, so it's going to be very similar to what we did when we had a number out front, but instead of making a new Y column, we're going to make a new X column. So let's go ahead and just get ready for that right now. Put some extra lines over here because we're going to need a new X column. Okay, now the one twist is when we make our new X column, instead of just multiplying by this number, we're going to multiply by the reciprocal, all right? Because everything under the radical is the opposite of the way it looks. Right now, this 1/2, you would think that would be a compression, a shrink. But it's really a stretch. So that's why instead of multiplying by negative 1/2, we're going to wind up multiplying by negative 2. All right, that's going to create the stretch that's really happening. Okay, but we'll come back to that in a minute. So first, we're going to start with the same X values that we always use for square root. All right, we always use 0, 1, 4, 9, and 16. And for the Y values, we're taking the square root of X, so that's going to always be 0, 1, 2, 3, and 4. That's not changing. Okay, but we have these new X values. We're going to have a new X column by multiplying all the old X values by negative 2. So that's going to give me 0, negative 2, negative 8, negative 18, and negative 32. So that's my new X column. So I'm going to throw out my old X column. So now I can go ahead and graph these points as sort of a parent function. So I've got 0, 0, negative 2, 1. I've got negative 8, 2. All right, so that's a little bit off the graph, but I can still graph it. So those 3 points will be enough to use. Now, what we haven't done yet are the horizontal and vertical translations, the slides. Because of the +1 right here, how will the graph move?
To the left.
Yeah, this is going to be to the left 1.
I thought that was parentheses.
Yeah, when you have a multiplier in front, you're going to have parentheses, but
I thought it was going to be
no, don't. Yeah, just leave it in this form with the parentheses to read it the way we're used to. All right, so in this form with the parentheses just like they are, this +1 means left 1. All right, what does this -2 mean on the end?
It's going down.
That means it's going down 2. Okay, so we need the parentheses, keep the parentheses. So we're going to take the 3 points that we graphed so far, and we're going to move them left 1 and down 2. Okay, so if I move, right, so left 1, down 2, so that's going to be here. All right, left 1, down 2. All right, this one's going to be even further off the graph, but that's okay. All right, so these points will show us the way to our final graph. So I'm just going to go ahead and draw my graph from the original point that started off at 0, 0. Obviously, it's going to the left. Make sure you have an arrow on the left and no arrow on the right. Okay, so that's it for the graph. Are you with me so far?
Yes.
Okay, now we can go back and talk about these other questions. Okay, the starting point, we're just talking about this point right here at -1, comma, -2. Okay, when we talk about whether the graph is increasing or decreasing, it's decreasing because we must read the graph from left to right and is going downhill from left to right. So that's decreasing. Okay, what do you think about the domain?
The domain will be at negative infinity to -1.
Correct, right? To the left, it goes forever, so that's negative infinity. To the right, it stops at -1. So negative infinity to -1. Put a square bracket on the -1. Similarly, the range from bottom to top is the order. So that's going to be from -2 to infinity. All right, and it has to be in that order. Bottom to top, -2 to infinity. Okay, now, absolute max or absolute min. Does this graph have a highest value? No. In fact, I mean, look at your range. It goes up forever. So there is no absolute max. All right, is there a lowest value? Yeah, you again just look at your range, right? The lowest value is -2. So there's an absolute min at -2. Okay, now end behavior. End behavior is all about as we go to the left, what do the y values do? And then as we go to the right, what do the y values do? Okay, so as we go to the left, what's happening to the y values?
The y value is going down.
No. As we go to the left, it's going up, 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 up. Okay, if as I go to the right, it's going down until we get to -2. But as we go to the left, it's rising. Okay, so as x approaches negative infinity, because to the left it goes forever, the y values just go up, up, up. So that's positive infinity. Okay, now I'm going to talk about what happens on the right. Does this graph go to the right forever? No. Where does it stop? What x? At -1. Okay, as far as the x values go, it's the end of the road is at -1. So as the x values approach -1, it goes to -2. Right? The y values are approaching -2. All right? And I think that's it for problem number 2. Wait, we were supposed to say all of the transformations. So I listed off a couple of them, but there are a couple more that we need to say. Okay, so we dealt with the +1 and the -2. That's left 1 and down 2. Now, when you look at the -1/2, these are two separate transformations. The 1/2 is going to be a transformation, and the negative sign is going to be a different transformation. Now, if this 1/2 was in front of the radical, this would be a vertical compression by a factor of 1/2. But under the radical, everything is the opposite of what I just said.
Horizontal compression.
That's right. So instead of being a vertical compression, which means shrink, it's going to be a horizontal stretch. It's going to be a horizontal stretch by a factor of 2. And I got the 2 by doing the reciprocal. It's exactly what we did when we made our new x column. We had to do the reciprocal. But I'm not going to say -2 because the negative sign is its own transformation.
Yeah, it's over the y
That's right. If this negative sign had been out in the front, we would have said reflection over the x-axis. When the negative sign is underneath the radical, that is a reflection over the y-axis. Okay, so those are the 4 transformations that we have, and that's going to do it for problem number 2. All right, let's take a look at number 3. Now notice this one is a cube root function, so that's going to change the x values that we're going to use. Numbers that we can easily take the cube root of are -8, -1, 0, 1, and 8. So we will use our usual 5 x values. Now the cube root of each of these numbers would be -2, -1, 0, 1, and 2. That never changes. Okay, now looking at this problem, we have an a value and a b value. There's a -1 in the front, and there's a -1 on the inside. Because of the a value, we're going to need a new y column. And specifically, we're going to wind up doing -1 times y. Now, because of the b value, which is also -1, we're going to need a new x column as well. All right, so let's go ahead and build on for a new x column. And we are going to do -1x. Now, to be clear, you don't just multiply by the b value. When you have a number under the radical, to make your new x column, you have to multiply by the reciprocal. But it just so happens that the reciprocal of -1 is still -1. Okay, so our new y column, if I multiply all these values by -1, I will get 2, +1, 0, -1, and -2. Okay, I can throw out the old y column. The new x column will be 8, +1, 0, -1, and -8. So there's my new x column. So these are the points that I'm going to graph first as my parent function. So 8, 2, all right, so that's going to be about here. 1, 1, 0, 0, -1, -1, and -8, -2. All right, now what we haven't done yet are the horizontal and vertical translations. Because of the -1 inside the parentheses, and again, do not distribute the -1. We want the parentheses to be there in order to read the motions, the translations properly. So with the parentheses, the x minus 1 means what?
Right.
It means to the right 1. So that's one of our transformations. And the +2 means what?
To the right. To the right cube.
Well, we already said to the right. So what does it mean when we're outside the radical? Up. Right, so that's up 2. So right 1 and up 2. So that's what we're going to do. We're going to move each of these 5 points right 1 and up 2. So that's going to be here, right 1 and up 2. Boom, boom, boom. Right 1 and up 2 would be about here. Okay, and these 5 dots show us where our final answer is. Okay, and this time make sure you have an arrow on both sides of the graph. So that's it for the graph. Now, cube root functions don't have a starting point. All right, because they just go forever in both directions. Is this increasing or decreasing? Well, from left to right, it's rising, so it's increasing. All right, always read that from left to right. The domain and range are both going to be negative infinity to positive infinity. Because the graph goes to the left and right forever, so that's the domain, and the graph goes down and up forever, so that's the range. Because of that, there will be no absolute maximum or absolute minimum, so we'll just say none. End behavior. The first part of end behavior describes what happens as you go to the left, what happens to the y values. So as we go to the left, in other words, as x approaches negative infinity, the y values are going down. So f of x approaches negative infinity. As we go to the right, in other words, as the graph approaches positive infinity, the y values are going up. So positive infinity. Okay, so that is it for problem number 3, except for we need to mention a couple more transformations. When you have a negative sign under the radical, that is a reflection over the y-axis. When you have a negative sign in the front, that is going to be a reflection over the x-axis. All right, so those are the 4 transformations here.